Good afternoon. Today you have the next session is to discuss the surveillance, maritime surveillance in the context of the extension the continental shelf, and we go start with Lindart Bal from EMSA, and please, Lindart, can you start your presentation, please?
Okay, thank you very much. Good afternoon to all. Thank you very much for inviting me to give an opportunity to speak. We are talking about maritime surveillance over the Atlantic, but I want to quickly explain also a bit the capabilities that we have. But first, one small word on EMSA, maybe on the next slide, please. So we are part of the European Union, a regulatory agency based in Lisbon, Portugal, where we give technical and operational support for everything what has to do with the maritime domain. We have 265 staff, 83 million per year, just to give you a bit of an idea of the magnitude or not of our organization. And we are working very much along 5 pillars: safety, sustainability, security, surveillance, simplification. But of course, we talk about surveillance. Next slide. We are already offering today to 5,000 governmental users in Europe maritime information systems in different domains. And here you see them depicted. I'm not going to repeat all of them, but we have already, let's say, big data sets with whom we help governments to improve their maritime surveillance capabilities. And I just would like to show a bit more about this on the next slide. So of course, also when you look at the Atlantic Ocean, it's a vast sea area which is very big. It means that we are using some terrestrial data, but actually most of the data that we are using overlooking big sea areas are satellite-based, actually in 2 categories, more the Earth observation part with the optical images and the radar images, and the vessel reporting systems like long-range identification and tracking, AIS, and the like. So very much, I think, satellite-based. So without satellites, I don't think we are able to monitor the seas. If you look at my next slide, you can already see that EMSA is collecting a lot of information on a daily basis. So we are collecting 35 million vessel positions worldwide per day. And those represent 80,000, more than 80,000 individual ships. That is complemented by our information, but also by satellite images, of which last year we had 13,000 images, meaning that we have more than 1,000 images per month to assist governmental authorities to understand what is happening at sea. That can be looking for pollution, but also looking for all type of vessels or human activity at sea for whatever purpose. And of course, that we need to correlate and to collect, to fuse, to make a powerful maritime picture that can be used by everybody. And I think there also we still can grow. And I will give you some hints at the end of my presentation, what I would like to see further developed in the next years by industry. If you look at the next slide, one of the most important information data sets nowadays is satellite AIS. There are only a handful of providers worldwide giving us information about the ship positions. And nowadays, the revisit time and the latency are very good. So in our agency, for multiple providers, we receive 25 million positions per day, which gives us a very accurate idea where ships are, even globally. Of course, we are very much interested in any EU interest, but that can also occur anywhere in the world. So these type of vessel positions are complemented, that you can see on the next slide, with Earth observation products. And actually at our agency, we have 3 different types of services: Clean SeaNet for pollution monitoring. Then we have our generic Copernicus Maritime Surveillance service, which we also use to support, for example, the Portuguese Navy in the Gulf of Guinea and also other activities of member states. And then we have a special project by which we support border control activities of Frontex as you are aware, in Europe, we have an enormous irregular migration challenge. And as we have very much the knowledge about satellite products and satellite information, we are the provider of Frontex of all satellite data types that they are using for their operations. As I am aware that I have many speakers behind me, I will try to speed up as much as possible. So on my next slide, I just have a very short illustration of the main types of Earth observation data that we are using to inform our authorities what is happening at sea. So you see an optical image on the bottom, and in the top a radar image. Radar image maybe is less appealing, but with radar you can always have an image, also during nighttime, when it's cloudy, when it is raining. And of course, for optical, you always need good weather. You can see that we are really pushing to have operational information, which means that we need to have it fast. So we are pushing also the industry to really deliver in a very short time, so that it is up to date as much as possible. So it is very relevant also for day-to-day operations. For example, on the next slide, you will see our current coverage of the Atlantic. Of course, we can cover any spot of the Atlantic, but this is based on user requirements, on users that want to have information. And it's obvious as a European agency that we are a bit biased, that of course we look very much at Europe, but also when there are interests anywhere else in the Atlantic, we also do acquisitions of satellite data elsewhere. And of course, we can also combine it with our vessel positions, as you see here also on the screen from the Caribbean, where you see a satellite image combined with vessel information, which you see very often. So I think the location is not an issue. If you have the capability, you can use it worldwide. Going to my next slide, not only satellite information can be helpful. Last 3-4 years, we started to develop our drone program to complement information from satellites and from vessel positioning systems. So we use it for different purposes. General maritime surveillance, for we have different types of drones used depending on the use case. But also specific, for example, for emission monitoring, as nowadays pollution and the climate is very much on the forefront of policies. So we are also measuring the pollution caused by ships on an individual basis with sniffer technology. That's very interesting and very promising. So not only, let's say, classical observation with cameras, but also with measuring gas emissions. For that, we use also satellite communication because the sea is big and you cannot always reach everywhere. So that we have a very wide range where we can use those drones that are, again, a kind of tool in our toolbox for compiling the maritime picture that we use. So for us, data is not in competition with other data or other technologies. We are very happy to combine everything we can get to compile a complete maritime picture. So in that sense, people ask, yes, but do you think that the satellite is better than a drone or vice versa? I don't think that's very relevant. I think we are happy with all we can get to compose a picture which is as complete as possible. On the next slide, you see a bit the other side of the coin. Of course, if you collect a lot of data, and I was already mentioning 35 million positions per day, the human eye cannot see and detect everything. So you need to have help from the computer to detect information that is relevant to you. So since 2014-15, we have developed a number of algorithms that can be introduced by the users to select data automatically. And that can be depending on particular type of activity, rendezvous at sea or drifting at sea, or if a ship goes in or out a particular area. And so by doing that, we have created 24 algorithms that can be used to help to select the information and get the alerts that our users really need. So that I think is very important to complement big data, is also to have the intelligent tools to really use the data on a day-to-day basis.
1 minute.
So I will skip my next two slides because they are two examples, and I will go to my last slide. Not to upset the chairman, just a bit of an overview of what is important for us. Actually, I want to focus on the two last ones. So of course, everybody knows vessel positioning information, satellite imagery. What we would like for the future is also to have the capability to detect, for example, satellite phones or radio signals at sea or telephone frequencies. That will further help to complement the maritime picture. And also, we find it very interesting, the new technology of what is called high altitude pseudo satellites, hubs, to have, again, an extra source of data that can help us to complement the maritime picture. And that, together with more artificial intelligence, will help us also to do a very good job over the Atlantic. And also there, EMSA would like to be at the service of anybody that has an interest in the Atlantic. And Chairman, I will stop here. Thank you very much. I hope I gave you a short shot of what our agency can do to look at the Atlantic. Thanks a lot.
Thank you very much. We will quickly jump to William to continue to talk about satellite applications related to the maritime surveillance and monitoring of the oceans. Please, William, the stage is for you now. William, you are there?
You're still muted.
I'm not muted.
Thank you. I would like to. Can you confirm you can see my presentation?
The presentation, yes, but not the PowerPoint presentation. We are seeing your screen, but okay, not the present. Now is the presentation. Now it's good. William, go.
Thank you. So I'm Senior Manager at Sales at Maxo Technologies, responsible for 10 countries in Western and Central Europe, NATO and the United Nations representations in Europe. Portugal is also under my purview. I am here to present material based specifically on the title of this panel, How to Build Strong Maritime Surveillance Ecosystems, the Challenges of the Continental Platform Extension and the Atlantic. Particularly taking on board also into full consideration the comments made by Vice Admiral Coelho Candido and Commander Jorge Garincha from their presentations earlier in the day. What you view here is but an eye candy of what our company concentrates on, what we are best at, and best at over the past 20 years. We supply the world with best in class, very high resolution electro-optical satellite imagery at 50, 40, and 30 centimeters. What you see here is an image of Porto Leixões. Our heritage has a number of well-known legacy brands such as GeoEye, Digital Globe, Radiant Solutions, even MDA that was once on board our group of companies and has now departed, and Space Systems Laurel, that is now part of our space structures section. We have legacy satellite systems such as Iconos and QuickBird, but also WorldView 4. We currently are running a fleet of satellites comprising WorldView 1, WorldView 2, WorldView 3, GeoEye 1, and we are heading towards a very exciting future as from early 2021, when our constellation of WorldView Legion satellites will be launched. The first batch of 6 satellites will be launched in 2021, but there will be more in the years following that. At this point, I would like to strongly recommend you to go to a events briefcase contained on the AED 2020 event website. Inside the events briefcase, you will see 3 pieces of material from Maxar: the Maxar company introduction, the Earth Intelligence presentation, and Worldview Legion presentation. I think they are well worth downloading, because you will see in there the level of quality. It really is a pleasure to view 30 centimeter low nadir angle imagery in its native resolution, not post-processed, native resolution. This is what our systems are capable of delivering. Here, as I've mentioned just a few minutes ago, we concentrate on the right side of this slide. Of course, we have access and contact with a number of industry partners, thus being able to supply our customers with a whole range of resolutions. But as per comments made by Commander Jorge Garincha, we're not here to prescribe the customer what they should need. We are presenting our capabilities, and this may or may not be compatible, partially or fully, with what the aspirations of the Portuguese armed forces, as well as, of course, PT Space, are. Another eye candy, this time of another section of the Port of Leixões, giving an idea of the crispiness and the level of resolution that you can rely on from our systems. In case you're asking yourself whether you can have this material, of course you can. I will make this material available to you via AED at the end of this presentation. So what I'm introducing here today, based on the title of this panel, is Earth Intelligence products, primarily by means of a maritime monitoring and security. I would not call it a system, but a system of systems. Basically, we have the best available imagery. We can extract information, therefore, in the best possible way from this imagery, and we can utilize either our own proprietary analysis systems, or we can have our imagery exported to third-party systems. So here's the section on the maritime domain awareness. The reasons why our products may be useful. If you look at the number of ropes at the stern of the 2 vessels, in fact 3, but primarily 2 vessels currently in action performing illicit fishing operations, you can see one of the compelling reasons why our products may be of use. Of course, there is a very well-developed AIS system comprising thousands of stations throughout the world, both maritime, space, and terrestrial. But what we see AIS as is but part of a whole that we can offer our customers through the MMS. So there are advantages and additions, complements to what is already available, as shown in this previous slide. I don't have enough time here to go into the intricacies of MMS, but I would very much welcome one-to-one email conversation and phone calls, Zoom conferences afterwards. This is another example of MMS in action off the Argentine coast. Again, being able to pinpoint as much detail as the ropes at the stern between the 2 vessels. Here, one of the advantages of our queuing systems within MMS, while you are, if you please observe point 1 on the left of this slide, while we are trying to track vessel number 1, we might land at additional goodies, such as being able to identify a submarine that was on dark mode, was not transmitting for obvious reasons, for understandable reasons at least, was not transmitting any signal for detection. But yes, we snatched that shot together with our collection mode and collection taskings for the particular region in question.
1 minute, William.
Sure, I'm just about to finish my presentation here. Some more eye candy where you can see the level of detail. Of course, we're not talking about covering the entire, hopefully upcoming exclusive economic zone of Portugal. This will be a colossal area. I have sailed personally from Vigo to the Azores. I know what region we're talking about, but we have access to synthetic aperture radar, electro-optical systems such as our own, and third-party systems. I would very much welcome to be granted the opportunity to further expand on this topic with industry and government, and especially the defense and intelligence realm of organizations likewise. So here is a very brief summary of what we are capable of offering to our customers. And please do not hesitate, get in touch with me at any time, later today or at any time to your convenience. Over to you.
Thank you. Thank you very much, William, to be compress your presentation, and you finish in time. We go jump quickly to André Oliveira to present the Musas project to us. I suppose André, okay, is now sharing. André, please go.
Thank you. Thank you very much. I hope everyone can hear me okay. First of all, thanks to the AED Days Organization Committee for the invitation to share the stage with such esteemed colleagues on a topic as interesting as this one, and for the opportunity to share our views on how to build a strong maritime surveillance ecosystem. I'm going to address this subject from a defense perspective, and we'll do this by presenting the PESCO initiative Muses. So I'm going to focus specifically on surveillance below the water surface. First of all, a quick note on SEIA. So we're an engineering and product development center located in Matosinhos in the north of Portugal, and we employ around 250 engineers and have over 14 years of involvement in complex projects such as Embraer's KC-390 aircraft design, or the Portuguese microsatellite project Infante, to name a few, as well as in complex operations such as EMSA's RPAS services. Our vision is basically to establish Portugal as a reference within key industries such as aerospace, maritime, and mobility, particularly in the development of technologies, products, and systems that are conceived, industrialized, and operated from Portugal. Okay, so today I'm going to speak about Muses. Muses stands for Maritime Unmanned System Anti-Submarine. And when we talk about maritime surveillance, specifically focusing below the water surface, we have a complete set of different challenges. So underwater surveillance is a very tough challenge and is especially focused on defense-related threats. Although there have been some cases of security threats, mostly related to drug trafficking using submarines. But there is a number of specific challenges from the environment. The 3D space is less known. So when we're talking about the underwater environment, it's very vast and not entirely mapped. So we don't know exactly what's below the surface. Threats are different also with respect to above surface threats. Mostly we're talking about submarines, which may be doing something as simple as gathering intelligence at the least, or threatening coastal territories and cities at the worst. Just for your reference, we have over 530 military purpose submarines divided in 50 different classes. So this is the range of different threats that we're looking at. Sensors are also different. Optics and radar are no longer the weapon of choice underwater. And acoustic sensors take the stage center and fronter. And of course, physics also plays a role. Here, light propagation, radio wave propagation, as well as sound propagation is different than in the surface. And pressure also poses a significant challenge to the design of vehicles and sensors. So when we're looking at underwater control, we consider 3 different areas of interest, and we usually classify them by color: blue waters, green waters, and brown waters. Blue water stands for the open ocean, green waters littoral and coastal areas, and brown waters river and estuarine areas. Currently, the most promising solutions appear to be combinations of all different kinds of assets and sensors, be those manned assets such as frigates, ocean patrol vessels, OPVs, helicopters, MPAs, marine patrol aircraft, unmanned assets such as UAVs or RPAS, both fixed wing and VTOL, vertical takeoff and landing, unmanned surface vehicles, unmanned underwater vehicles, ROVs, etc. We also consider static and mobile sensors. Static sensors like buoys, hydrophones, mobile sensors such as those being proposed under NATO's ASW barrier work, and of course, decision support and artificial intelligence. This to face the increasing amount of data, the increasing amount of vehicles, and the complexity in combining all of these different vehicles and data into creating a single maritime picture. MUSES is a PESCO initiative, which is led by Portugal and involves France, Sweden, Spain, and Italy and Belgium as observers. And it's focused on developing or addressing command, control, and communication, so C3 aspects of a mixed man and manned force dedicated to anti-submarine warfare missions. PESCO, as you might or might not know, stands for Permanent Structured Cooperation and is essentially a framework and process whereby EU member states, which are willing to cooperate, commit to invest, plan, develop, and operate defense capabilities in a cooperative mode or jointly. And so Portugal has proposed this initiative, has gathered support from these nations, and we're currently initiating the project, which has several different types of high-level requirements, some of which you can see here on the screen, stemming from aspects such as ensuring resilience to cyber threats, ease of maintenance, simulation planning, and perhaps more importantly, an open architecture, the application of common standards, and a service-oriented approach that fosters interoperability between different unmanned assets and different sensors from a wide variety of manufacturers. These are seen as very necessary conditions in order to create the thriving ecosystem of suppliers for underwater maritime surveillance. So to quickly conclude, I have a couple of slides just on the challenges and opportunities for industry of being involved in, sorry, I think I skipped one slide, yes. To provide you an overview of where we stand right now. So each nation has appointed an industrial point of contact, and we have established industrial capacity across the participating member states. The nations are currently developing the operational concept and the common staff targets for MUSES. And on the industry side, we're pursuing funding to support the design and development of the MUSES solution according to the joint requirements that are being set up by the nations. And to conclude, challenges and opportunities for industry in this sort of work. So we do have a number of challenges that we need to address. First and foremost, we need to secure and capture funding to support the development activities, because PESCO in itself is not a funding mechanism, is a cooperation framework. And we do need to solve very complex technical problems. We need to take into account that all of these different unmanned systems that are currently on the market usually use their own ground control stations. They don't follow necessarily a common standard, which means that if you try to equip a number of different systems on board a vessel, you will likely have a number of different control stations and containers aboard a ship just to control the different unmanned systems. We need to be able to ensure that these systems talk to each other, they talk to the vessel. We need to be able to allocate and use the resources that we have at our disposal in an adequate fashion. All of this while reducing the workload for operators. So we don't want the operators to be overwhelmed by the data that they're receiving, which is the basis for the intelligence that they will generate about the situation. As well as we don't want to generate overload from having to control all these different types of assets. And of course, we need to be able to fuse data from all these different heterogeneous sources.
1 minute, Andre.
Okay, thank you. And so it's important to design tools and interoperability solutions that gather support from other industrial players. And this is especially important to generate critical mass of adopters. So this is probably the biggest challenge, I would say, which is to ensure that both navies as well as an industry adopt this kind of open architecture, interoperable system in order to create an ecosystem of anti-submarine tools that can be used by the navies to create a system that is effective and caters to different needs of different nations. And my final slide, this also poses some opportunities for industry, namely the opportunity to do co-design directly with the end users, because we're working essentially directly with the nations on the development of the concept of operations and common staff targets. It also creates the opportunity for increased trust, cooperation, and lower risk. And this results from the fact that the member states have jointly committed to this initiative, to the requirements, to the CONOPS, and to the development and operation of these defense capabilities. It provides the chance to steer the birth and evolution of an ecosystem of anti-submarine warfare tools and suppliers. And of course, it paves the way also for new unmanned vehicles and concepts for underwater control. And that's it for me.
Thank you, Andre. And I ask Sasha to start to prepare the presentation. Sasha go to present command and control proposal from Airbus. Please, Sasha, you can start. The stage is yours.
Okay, thank you. So do you hear me?
Very well, but you are not sharing the PowerPoint. You are sharing the application and not the presentation.
Yes, wait up. So now it's okay?
Now it's the presentation. It's nice. Please go.
Okay, thank you. First of all, I want to thank Lendert and William, who will make my presentation much shorter and easier, with Lendert, who mentioned the complementarity of assets and the holistic approach, and William, the added value brought by Earth observation satellites. So I will focus my speech about the holistic way Airbus could answer to the threats and the problems that you can face in such a remote area or such a big area as the Portuguese continental shelf. About the main threats you have in the Portuguese waters, I will not extend on it because I think it was already mentioned, and some people are much more expert in these domains than I am, so I will not go more into detail. So here's something that is quite interesting, because usually when people are thinking about Airbus, they don't think about the maritime domain, but instead Airbus is very, very present in the maritime domain. As you can see, of course, we have the airplanes and the helicopters. This is self-evident, and in particular in Portugal with the C295 MPA. But Airbus is also providing unmanned airborne systems, fixed wing or rotary wing, and the one Leonard mentioned, so high altitude pseudo satellites like Zephyr, that is making some trial flights at the moment in the USA and in Australia. We are also providing Earth observation through our own constellation, both optical, with the famous spots, so from decades ago, Pleiades, and we are launching at the beginning of next year Pleiades Neo, so for very high resolution. We also have our own SAR constellation with a TerraSAR X, Tandem X, and the partnership with RPAS. And we have now a partnership with a radio frequency interception constellation called Hawkeye 360, in which Airbus put some big hopes, especially in the maritime domain. In fact, Airbus took shares in this company and has exclusivity for Europe. So with all this, this was for the satellite part. We are also providing maritime intelligence systems based on big data analytics and so on, from the expertise we had from our, let's say, historical companies, Astrium, Cassidian, and so on, that were working in the intelligence area. Now we are making naval intelligence systems for the French Navy and also for others. And the last point, quite well known in Portugal, is the coastal surveillance system based on our technology called Styrus, that is already equipping the Portuguese vessel traffic system. And so our challenge at Airbus is to bring all these assets together in a layered, holistic approach that allows, in fact, detection from very, very far away, then tracking closer on, and then really real-time tracking when it goes close to the coast, and all this so optimized through our own C4 ISR. I will not go into the products because, as you know, we have a lot of them, so it will not last 10 minutes, but 10 hours. And you will find all this in the backup slides. So I will rather go on some use cases we worked on in the latest weeks or months. What you see here is some work we made for Australia and New Zealand about a kind of layered approach between both countries, where in fact for the wide area surveillance, we would use satellite detection through SAR or radio frequency. When we're still very far away from the coastline, then relocation, classification, identification through EO satellites, and then getting closer using maritime patrol aircrafts for tracking. And at the end, once the OPV intercepted the ship or the target, a UAS monitoring in order to ensure that everything is going safe. And so this is exactly what we're working on. So it's not one single capability, but it's a complete holistic concept covering the complete mission. Some examples and use cases we performed lately. So this is a quite interesting one. We performed with Hawkeye off Galapagos Islands. And in fact, so this is highlighting one point Leendert mentioned. If you're looking only at AIS, you will see that surprisingly, all the ships are just out of the Galapagos EEZ and nobody's in. When you're using some other sensors like radio frequency or SAR, then you discover a reality with some ships, some fishing vessels just turning off AIS, going to fish illegally in Galapagos waters, getting out and putting AIS on again. So there's one point I want to mention. So AIS, it's very nice for our engineers. They love it because it's a big data. They can use analytics on this, but it's not reality. If you want to know reality, you need a combination of assets. So in these remote areas, mainly satellite-based, optical SAR, radio frequency. It can be airplanes on or other, but so AIS is not the reality of what is happening at sea. Second point that was quite interesting, I think everybody heard about the big pollution that happened off the coast of Brazil last summer. And in fact, at one point, we got the request to determine so the nature of the pollution, but also who could be the polluter. And so in fact, for this, it implied two assets. First, our SAR and satellite imagery to determine the pollution, what you can see on the top here, and then determine what, so who could be responsible of it. And so in fact, we used our AIS analytics and our experts we have in-house to determine first, so what kind of ship could spill this kind of oil. So it was heavy crude oil, so it was not a container ship or something like this, it was a tanker. And then through our analytics, determining through geofencing and historical data, the ships that were from this type that was sailing around the start of the pollution, exactly the 29th of July, 2019. And at the end, in fact, the Brazilian police with their investigation confirmed the data we've been transmitting to them earlier in this period. And so had some good evidence on the suspicious vessel. Third case, so quite known, unfortunately, Beirut. So the use of satellite imagery for disaster relief. Here you can see Beirut, in fact, before the explosion in the harbor and right after. You can see so on the red lines, the crater created by the explosion. In fact, this work was requested by the French Navy.
1 minute, Sacha.
Okay, so you understand the system. So change detection for operational use. In this case, in order for the French Navy to get in the harbor to bring some help. So this was after a typhoon happening in the Pacific. And the very last example I wanted to show is when it goes really close to the coastline, the use of the coastal systems. In this case, it was some go-fasts going from Sardinia to the French Riviera, 45 knots. And in fact, so there was initial detection by our signal stations of Corsica, following the go-fast all the way along Corsica, then tracking through helicopters, interception by the customs. And in the future, I think everybody heard about the future combat air system. This will be supported by also cloud technology, what we call the multi-domain combat cloud. We are also developing now for the maritime domain, so a complete cloud infrastructure, both public and private, with all the analytics that are going with it. And that's it on my side. So for any question on whatever the product is, don't hesitate to contact me. It will be a pleasure for me to answer to your questions.
Thank you very much, Sacha, to be on time. Now, until now, we have one presentation with requirements coming from ENSA and specifications, two offers from Airbus and Maxes offer some products and some ideas about solve some monitoring problems and maritime surveillance. We also listened, Andre, to talk about a future project about the defense, underwater defense. And now I want to have a perspective from Portuguese government and Portuguese authorities. And I ask Sandra to give you a perspective in the context of this maritime surveillance and monitoring the oceans. We know what is the orientation to be designed now with the sea minister structure to address these topics in the next decade. Please, Sandra.
Thank you. Thank you very much. I don't have any presentation to present to you. I will only speak about what you asked me for. Yes, I'm Sandra Silva and I'm from Director General for Maritime Policy. And this Director General is under the Ministry of the Sea. And just to give you a short, briefly presentation, what DGPN's main mission is to develop, evaluate and update the national strategy for the sea, and also to elaborate and propose the national policies for the sea and its various aspects. And also to plan and order the maritime space in its different uses and activities, monitor and participate in the development of the European Union's integrated maritime policy, and also to promote national and international cooperation between the sea. And we are on time at this moment, developing and designing the new national strategy for the sea for the next decades. And this strategy is a public policy instrument that presents the Portuguese vision, objectives, areas of intervention and goals for the period 2021-2030 with regard of the ocean's development model. This model starts from the ocean as one of the main pillars of sustainability out of the planet and is based on the principles of preservation and sustainable use of the resources and services of marine ecosystems in harmony with the economic, social and environmental development that is intended for Portugal until 2030. And in this new strategic that is being developed, there are several strategic objectives, and one of those is ensuring security, sovereignty, cooperation and governance, and also has as a prioritary intervention area, maritime security, defense and surveillance. And in this new strategy, we can see a target to achieve until 2030. And this is specifically what the scope of this workshop we are talking about, is to complete the process of extending the Portuguese continental shelf. And to achieve this objective, this strategic objective that I mentioned, is proposed to be implemented several measures. Some of them I will share with you to give you an overview what will be the path for the next decade. One of the measures is create a monitoring network to ensure the sovereignty of resources of the continental shelf. Is also to ensure that the implementation of this national strategy as the national instrument of the European integrated maritime policy is in line with the implementation of other maritime integrated policies like Common Information Sharing Environment, the CISE, the National Maritime Special Planning, and the Marine Strategic Framework Directive as an environmental pillar. It also will develop a national maritime safety strategy in line with the European Union's maritime safety strategy. It is proposed to develop a program for the construction of naval means manned and unmanned for surveillance, inspection and control for the ocean zone and also for the coastal zone up to 12 miles. It will also to develop the integrated command and control network that gathers information from the information systems of the security forces like Guarda Nacional Republicana and the Maritime Policy, and also defense and port control. Well, another measure could be develop an integrated network under the responsibility of the National Maritime Authority for inspection, control, and surveillance of nautical recreational activities. Implement an integrated surveillance, inspection, control, and security network. Operationalize the Atlantic Observatory in coordination with the Air Center, ensuring the efficient allocation of European structural and investment funds to the strengthening the strategic economic potential of the sea economy, ensuring also environmental sustainability and marine resources. So this is a strategic priority that Portugal should give to maritime security in its environmental, economical, social, and geopolitical dimensions, as it is an essential condition to promote the quality of the environment, economic sustainability, and human security. And this sector directly drives science and innovation, robotics and digital technologies, the development and marine surveillance systems, information and communication systems used in marine security and surveillance and operational activities, giving to the industry the opportunity to provide products, services, and technologies in response to those needs. So this strategy national for the sea is during these months of October in public consultation. So it is open to all society, to the industry, to all the government entities that should participate in this public consultation for the strategic fund national of the sea. And just in a resume, and after seeing all these presentations, I should say that that is the path, and this is an ecosystem for sure, because at the end of the day, the main words that we can collect here is data collection, data storage, information, share information, and all of this is an instrument needed for all the stakeholders and the actors in this maritime surveillance and security domain, because this information will help political decision makers, will help maritime authorities, entities, and we need industry, we need research community to go together in the same ecosystem to find the best solutions. As it says in some kind of presentations, there are still many challenges to achieve and needs to be fulfilled between the new development in the technological, the knowledge. So it is very important that the industry and the other side of the government entities and marine authorities to work together in finding these services, technologies, products, solutions in order to fulfill all these objectives and these priorities that I mentioned in our national strategy for the sea. So thank you very much. Just another thing, funding was also a theme that was presented in one presentation. The GPM has also the responsibility to manage two funds, the Blue Fund and the EE Grants Blue Growth Program. And I should disseminate between you that at this moment, this program is ongoing. We have an open call for research, and the surveillance and the monitoring environment is one of the scope of these thematic areas of this call. And also in the business development and innovation part of the program, we will open another call, and the industry could apply regarding the development of these new solutions and technologies and services within also the scope of this workshop. So thank you so much, and I'm available to present you any clarification.
Thank you, Sandra, for so complete answer, and you fulfill a lot of different spectra from the problem, and I suppose the industry, the people from industry catch very well the idea and see a lot of the opportunities coming from next decade. And for finish, I have one question for the people from the industry. Maybe Airbus or Maxar can answer to me. I watch with careful your presentations, but you talk about holistic things, but I don't see any synergy with natural hazards also. You only focus in the man-made hazards or man-made illegalities, but the same sensors, the same constellations, the same equipment, the same image is also possible to use for the natural hazards, climate change monitoring, hurricanes, and so on. I don't see this monitoring and surveillance independent, the defense and safety independent from climate or environment and so on. Can you?
Yes, sure.
Back? 1 minute only, I know, but we start late. Please, Rui, let the Maxar or Airbus answer to these questions.
Yes, Sasha speaking. So just one short point about this. You gave us only 10 minutes, so it was a bit complicated. But we had also some studies about the Sargassos issue in the Caribbean, or the ice monitoring or things like this. So it's something we are perfectly able to do. So next time, give me 10 more minutes and you will see it.
Okay.
Well, from my side, suffice to say that Maxar is one of the United Nations partner companies for the Sustainable Development Goals. Rest assured, we have many models that incorporates the usage of our imagery and systems and data analysis for the purposes of natural hazards monitoring and hopefully prevention of those catastrophes which are the result of natural hazards. However, I've had the chance to merely scratch the surface of what our capabilities are during today's presentation in order to honor our time schedule. Thank you.
Thank you very much for all. I want also thanks to the organization to give the opportunity to moderate this panel, and we save 4 minutes. Okay, please, thank you very much, and I hope to see you in the next presentations. Bye bye.
Thank you.
Thank you. Bye-bye.
Thank you very much, Eduardo, for